Hello students, good morning everyone. I right. Yes, yes students, I hope there was power cut. Now it has resumed. I hope you are getting clearly now. Right. What is current density and what is drift velocity? So current density can be defined as a vector whose magnitude is equal to current per unit area. Say, yes, note down. Current density, right? Current density, it is denoted by J. Okay, what is current density? A vector I can define it as a vector having magnitude, a vector having magnitude equal magnitude of, just while defining, you can define in different ways. A vector having magnitude of current per unit area, current per unit area is called current density. Is called current density. So, in case of a conductor, a given conductor at some point, at a given point, you can say, okay, a vector having magnitude of current per unit area is called current per unit area is called current density. So, how can you give this mathematically? How can you measure this? So, you can just simply it is given as we can give this in simplest form as current density J is equal to current per delta I by delta A, limit delta t tends to 0 can also be, actually this gives was a the limiting value of delta I by delta A can be called delta I is different. Can take it as when you have discussed about average current, instantaneous current, this kind of notation we are taking here. So when delta, sorry, here we are not having delta t, delta A tends to 0, delta A tends to 0. This can also be expressed as, this limiting value of delta I by delta A can be taken as di by dA, di by dA. And what is the direction of current density vector? It can be given as n cap. If a component of area element is given, then it can also be expressed as something like this: J is equal to delta I by delta A cos theta, the normal component of area. It can be taken as delta A cos theta also. From this, You can write delta I, delta A, you can write dA also. So you can write it as di by dA cos theta. From this you can write, you can write here di is equal to j into dA cos theta, as it is in the form of AB cos theta form. You know, in a product AB cos theta can be written as dot product of two components A dot B. Similarly, you can write this as J vector A, okay, J vector dot dA vector. Right. So here, in terms of current density, if you want to find the current, we can write, you have to take integration. Integral of di is equal to integral of j vector dot dA vector. Right. So integral of di gives I. So the current I is equal to integral of j vector dot dA vector. If the vectors are given in components form, you can directly use this. Right. Yes, something has happened to this. One note. This is talking. Let me close this and open. It is not opening. One note. This kind of technical issues will come across many times. Right. I see. So this can be taken as the expression for current and current density and relation in them. Okay, if j vector dot dA vector, if the j vector and a dA vector, current density vector and area vector are given in components form, you can make use of this relation. Okay, you can also write it jx ax plus jy ax dx plus jx dx plus jy dy plus jz dz, etc. So this will simplification part of this gives you the current. While doing the numericals, you have to make use of, even in Neet, JE, or even some. From this, we can write the units and dimensions of current density in simplest form. Let us see here, units and dimensions of current density. Units and dimensions of current density J. Units and dimensions of current density J. So as current density in short is expressed as current per unit area. Current per unit area is a vector, okay, having magnitude equal to current per unit area. So SI unit of current density is given by SI unit of current by SI unit of area. So that is ampere per meter square. So say SI unit of current density J is ampere per meter square. Ampere per meter square. Simply. How to write the dimensional formula of this? Dimensional formula of current density J is, in the dimensional equation form, you can write dimensional equation of J is equal to, as it is ampere meter per meter square. You can write it as meter is unit of what? Length. So L power minus 2 A power 1, or you can write A power 1 L power minus 2 as well, or in terms of MLT, this is how you can write in terms of MLT, the dimensional formula of current density. So current density is a scalar vector. Is a scalar. Sorry, is a vector. Its direction should be along the unit normal of the given area at a given point. This is briefly about current density. Next, what is drift velocity? What is drift velocity? What is drift velocity? Drift velocity, let us denote by V suffix D. Velocity. So, just let us consider a small conductor here to understand the meaning of drift velocity. And we have also already discussed that usually if you have a conductor, it will have free electrons and at room temperature, due to thermal energy, they will be under random motion. They undergo random collisions, and hence the conductor will not contribute or constitute any current. Net current will be zero. Whereas if develops an electric field across the ends of the conductor, that electric field will direct from positive to negative, and as a result, force acts on if electric field, hence electric field will develop here in this direction. As a result, electric force, as we know, force F is equal to Q into E. So if you have a number of electrons here, electrons, okay, these are on X. If the charge of the particle is minus E, you can then minus E into E will be the force acting on the each charged particle. That means here in vector form, if direction will be in opposite direction to electric field, that means in this direction force acts. Force acts. As a result, the electrons move in this direction because of the external power supply or external agent. So the electrons start moving from right to left, and as a result, if you say the conductor is having area A, uniform area A throughout, and if it is having length L, the electrons will be aligned in this direction, and hence they will be drifted from right to left. And of course, during these motions, they will be undergoing few collisions, but overall, because of the energy supplied by this battery, they will gain enough energy and they travel from right hand to left hand. Even after undergoing number of collisions, like they will not directly move like this. They may undergo some collisions here, then move here, and then again undergo some collisions, then move here like this. Then finally, they will reach the other end and contribute the current. They will, when the electrons are moving from right to left, current direction, conventional current direction will be taken in opposite direction. Okay, so that's how you can say current will be flowing in the stop. The velocity is obtained in different cases, maybe v1, v2, v3, and so on, vn. So average of all these velocities in traveling from one of the conductor under the supply of external electric field or potential difference is called a drift velocity in simplest form. So what is drift velocity? The average velocity gained by electrons. The average velocity gained by electrons in traveling from one end to another end of a conductor. Traveling from to another end of a conductor, from one end to another end of a conductor by an external due to an external electric field, due to clearly due to external electric field, is called drift velocity, drift velocity VD. right? This drift velocity can be obtained in different forms, different ways, in different what do you call, in terms of different quantities. So we want the drift velocity in terms of current. So let us take the subheading drift velocity in terms of current and current density. Drift velocity in terms of current I and current density J. Current in terms of current and current density J. So drift velocity in terms of current I and current density J. How to express this? So again, let us try to draw that conductor here for the reference. This is a conductor, right? It is connected to a battery. Especially in board point of view, you have to write some small description, guys. But of course, as a conceptually, you can remember the points. Okay, consider you can write like this. As consider a uniform conductor, a conductor of uniform area, a uniform conductor of area A is considered a uniform conductor of area A and length L and length L connected to a battery as in figure, connected to a battery of potential difference of PD means potential difference V volts, V volts as in figure. Draw this one, figure, simplest form. Now the current through the conductor is given by the current through the conductor is given by I is equal to Q by T. The total current charge per unit time is called in general current, Q by T. Okay, let us take this as equation 1. Let us take this as equation 1. Just a second, guys. Right, yes, yes. Okay. Yeah. Yes, okay. Yeah. So current through a conductor is given by A is equal to Q by T, where where Q is equal to the total charge passing through the conductor. Q, you can write it as is nothing but total charge, total charge, simply total charge. Total charge means total charge passing through a given cross section of the conductor in any time. So that total charge is given by, if you consider small n is a charge per unit volume, then this into number of charge of each carrier E gives total charge. So total charge is equal to NAL into E, where what is this? You can take this as equation 2, where unit volume and A into L gives total volume of electron, or magnitude electron, magnitude only are considering as magnitude of charge of electron. So that gives the total charge which is passing per unit time. So if you substitute that in equation 1, you can write current I is equal to Q is N A into L into E by T. So this can also be expressed as N E A into L velocity, drift velocity. You can replace this, and you can rewrite this as, that implies, this gives I is equal to NEA into VD. Here you can write, because L by T is equal to VD, that is drift velocity. Okay, so this is usually the relation between current and drift velocity, or you can also write it as VD is equal to, in terms of drift velocity form, A is the expression for drift velocity in terms of current in terms of drift velocity in terms of current. As if you are asked in terms of current density, so then we can replace I by A with the current density. As you know, here you can write this as VD is equal to, this implies VD is equal to J by N into E, because I by A, current per unit area, is nothing but J, that is current density. So you can replace this with the drift velocity loss. So this is how you can get that. And of course here you have to remember one small related quantity also, that is mobility. Let me give you that also, then we'll see some questions. Mobility, let us see what is this next quantity, small quantity, mobility of charge carriers. Mobility, okay, it is denoted by symbol mu. What is this mobility, or mobility of charge carriers? So mobility, so if you have a conductor, same conductor, if you connect this connector to an external source of EMF, V volts, then electrons are moving in this direction. Electrons are drifting in this direction due to the force, given by this external potential difference, velocity. And due to the external force, or you can say external field developed, external field is developed here. If you change the potential difference here, field value will change. Of course, L is a constant here. So as field changes, force acting on the electrons changes, so more number of electrons will be drifted towards left in unit time only. That means the more number of electrons will mobilize. Mobilize means moved. This terminology is giving you a new quantity called mobility here. Mobility can be simply defined as mobility of, here in this case, charge carriers. Mobility of, in this case, electrons. In general, even for protons also can define for any kind of carrier. So mobility of charge carrier in general. Mobility of charge carriers, right? Either electrons or protons, is defined as drift velocity gained per unit electric field. Velocity when defined like this: drift velocity gained per unit electric field, per unit electric field. So how can you express this mathematically, and how can you measure this? Is Mobility is given as, you can write magnitude of drift velocity without the negative sign. Okay, that gives mobility. So mobility depends on usually the pressure and temperature. You have to keep in mind this, that mobility mu depends for a given conductor for this given E, we will fix it. So it is a constant, but it changes if temperature changes, if pressure changes. So mu depends on pressure and temperature. Pressure and temperature. So what the units and dimensions of mobility also. S unit of drift velocity by S unit of electric field will give you S unit of mobility. So how can you write the unit of mobility? Here you can write as a note SI unit of SI unit of mobility mu is drift velocity is meter per second. Meter per, right here as mu is equal to V by E. So the unit of velocity is meter by second for electric field, as it is force by F by Q. So you can say Newton per coulomb. So meter coulomb per Newton second. So you can write it as meter hyphen per second. This is one of the way you can write. The other way, you can also express this is drift velocity and relation between current and current density. Okay, relation between drift velocity and current, relation between drift velocity and current density. So, what kind of questions can be asked based on this? Let us see just a couple of questions. Right. Mm, so, let us see one or two reason and assertion based questions based on this. Yeah, reason and assertion based questions, and few other kind of questions also. Let me check. Reason as a star note. Mm. Yeah, so a small question. So the number density of electrons, just you can take this question. Let's see a question. Of electrons, write down the question also and you can practice, guys. The number density, the number density of free electrons in a copper conductor, of free electrons in a copper conductor, in a copper conductor, estimated is 8.5 into 10 to the power 28 per meter cube, number density. How long does an electron, how long, how long does an electron take to drift from one end of the wire to another end? How long does an electron take to drift from one end of a wire of length 3 meters to to another end is a question provided. The area of cross section of the wire is given by, here you can write given area of cross section, given area of cross section of the wire, area A is equal to 2 into 10 to the power minus 6 meter square, and current passing through the conductor I is equal to 3 ampere. Here I have to take this as n is equal to 8.5 into 10 to the power 28 per meter cube. The unit should be per meter cube. And how long does it takes to travel from one end to another end? Means what is the time taken to travel these electrons from one end to another end? Provided length of the conductor 2 into 10 to the power minus 6 meter square, means 2 micrometer square, and current to the conductor I is equal to 3 ampere. So how to get this? What else is given here? These are the, what do you call it, parameters given. So you know what is the relation between the time and length and area and current? The current I is equal to NEAVD, drift velocity. VD is drift velocity. Current is given here, so we can find the drift velocity VD is equal to I by NEA. So where I is given as 3 ampere. Got it? 3 ampere. Take this as 3 by n is number of electrons per unit volume, so is 8.5 into 10 to the power minus plus 28 is n. E, charge of electron is 1.6 into 10 to the power minus 19 coulomb. Not given small e. Still you have to remember what is the magnitude of charge of electron. So 1.6 into 10 to the power minus 19. And area is 2 into 10 to the power minus 6. 2 into 10 to the power minus 6. You have to simplify this. If you simplify, you will get V value. So simplify and get the V value. Right? Then you have to say, also we know that I is equal to, as while deriving the expression, if you remember, as Q by T, which is equal to N into the total charge passed, is equal to number of charges per unit volume at drift velocity here. Directly from this only you can calculate. Yeah. So as this is the given expression, from this itself you can calculate. Otherwise, just you can get the relation of I equal to any VD. Then again you can simplify. You can get that. That's why you can do it. So here this is equal to VD. I equal to NEA VD. But NEA VD. So here we are asked to find what is T. Yes, from one end of the conductor to another end having length L is T is equal to L by VD. So here substitute the values of L and VD, you can calculate. You can get, otherwise directly from this also you can get it. So L is what? Drift velocity, you have to calculate from that, and you have to substitute it here. That will give you the time taken for about the charge carriers to drift from one end to another end. Got it? So directly the other way, this is after calculation of drift velocity you can substitute, or directly you can say, you can calculate by use, take it as I is equal to, you calculate VD and substitute, guys. I'm not doing the calculations here. Is equal to NEAVD, of course, but total charge is number of charge carriers per unit volume into total volume. total volume is A into L into charge of each carrier, E by T. Here you are asked to find T. So you can take T is equal to NEAL by I. So here every parameters in this expression are given. E you should remember. Then if you substitute, N is number of charge carriers per unit volume is 8.5 into 10 to the power 28. 28 into charge of each carrier is 1.6 into 10 to the power minus 19 coulomb. The area is given as 2 into 10 power minus 6. 2 into 10 to the power minus 6, and length is given as 3 meters divided by current in the conductor is given as 3 ampere. 3 ampere. This is a simplest way of calculation. Okay, so here 3 ampere. So 3 gets cancelled. So you can 1.6 into 2. So 16 into 2 is 32. So you can write it as 3.2 into 10 to the power minus 19 minus 6 minus 25. 28 minus 25 gives you 28 minus 25 gives you 3. Right? Yeah, 3. So this is a time taken by the conductor. So 8.5 into 3.2 you have to, but you shouldn't use calculator. You have without using calculators you have to do it. 3.2. 8.5 into 3.2. So it is equal to 27.2 into 10 to the power 3 seconds is the time taken by this many seconds it takes to travel from one end to another end. This is how we can calculate. Okay, and the questions may come based on this drift velocity concept. So okay guys, so here you can adapt this instead of calculating drift velocity first and doing this. So because some students may think that way also, so just you need to have an idea of different ways of doing. This is the best way. So that